Today's lesson is on 4.7, Transformations of Polynomial Functions. So we're first going to start with this opening question. Apply the following transformations to first a quadratic function. So we're going to revisit transformations of quadratics because a lot of the same things apply to any higher degree polynomial as well. So if f of x here equals x plus 5 squared, we want to vertical shrink by 1/2, translation right 2, then finally vertical translation down 1. So I'm just going to go ahead and start and apply all those transformations before I look at these options and then try and match my answer. So I have f of x equals x plus 5 squared. Now my first step is vertical shrink by 1/2. Remember, vertical goes on the outside, so that now we have 1/2 times x plus 5 squared. Okay, now I'm going to go ahead and move on translation right 2. Remember, that's going to be inside the parentheses, and we subtract 2. It's kind of the opposite of what we think. So now we have, and I'm going to x plus 5, and then I'm subtracting 2, which gives me 1/2 x plus 3 squared. All right, and then finally we have translation down 1, vertical, so it's on the outside. So our final answer will be 1/2 x plus 3. Right, nothing's happening on the inside, but I'm subtracting 1 on the outside. So I get 1/2 x plus 3 minus 1, which is option C, 1/2 x plus 3 minus 1. So we're going to take what we know about translations of quadratics and apply them to polynomials. So like I said, all of the same rules kind of apply. So anytime we're doing horizontal translations, left or right, we're subtracting on the inside. The difference will be we have to make sure we do it to every single term, which you'll see here in a little bit. Vertical translations still happen on the outside here. Reflections over the y-axis, remember, goes on the inside. Over the x-axis goes on the outside. We mostly focus on over the x-axis, but we need to be able to know both. Horizontal stretch or shrinks, remember, they flip. So if I want to shrink by 1/2, I'm inside multiplying by 2. And if I wanted to stretch by 2, I would be multiplying by 1/2, remember, on the inside. Vertical stretch or shrinks stay the same, and those are again on the outside. In order to understand transformations, we need to be able to recognize those parent functions and what those graphs look like. So we've seen a ton of x cubed. That's no surprise. X to the 4th. This has been mentioned, but just to make sure everyone's on the same page, much like a quadratic, it just flattens out a little bit at that x-axis. But it's important to note that that center point is at 0, 0. Same with x cubed, x to the 5th, again, much like that x cubed function, but it just is stretches out a little more fat at that x-axis. And then again, notice x to the 6th and x to the 4th, very similar, as well as x squared. If we remember x squared, that's going to be like this, right? It's just touching once here. Right, so that would be what our x squared function looks like. All of them very similar. It's just the higher power we get, it's going to get a little more fat, and that's just going to continue for all even powers. And same with odd, that's just going to get a little more flat and stretch out the higher the power it goes. So here, describe the transformation of f of x cubed, represented by x plus 5 cubed plus 2, then graph each function. So we see, this is our original function. What happened? When we add 5, remember that's going to move it left 5. Now, what else is different? Our plus 2, that moves it up 2. Okay, so that would be describing the transformation. I will graph our parent function in red. Remember that inflection point happens at 0, 0. So that's our parent function, and then I'll graph g of x in orange. And that's moving this point left 5, 1, 2, 3, 4, 5, and up 2. Okay, so that's kind of that point there. Okay, and just rough sketches, that's all we need for this. Write the rule g of x that represents the following transformation. So we're starting with f of x equals x to the fourth plus 2x squared minus 4. So remember, let's do these one at a time because we have to first complete that entire first step before we can move on. So we first look at vertical stretch by 3. Remember, vertical stretches, we multiply on the outside, but we have to multiply everything. So we have 3 times x to the fourth plus 2x squared minus 4. Now here's what's different. We have to distribute this to every single term. Okay, so now we have, I'll write g of x here, 3x to the fourth plus 6x squared minus 12. Okay, now we're done with that step. We can move on. Followed by a translation right 2. So remember, right 2 is going to be subtract 2, but on the inside. And that has to happen to each and every term. So wherever we see an x, we have to subtract 2. And remember that 4 or to the fourth power goes on the outside, just like it would as if we were doing a quadratic. Okay, now we do the same thing. Turns into an x minus 2 minus 12. Okay, and then we have nothing left to do. This would be our final answer. All right, so let's do a quick check of that. I want you to pause the video, apply this transformation to our function f of x here. First, go ahead and complete the transformation, then find which answer matches correctly. So go ahead, pause the video and do that. So I'm going to first start, again, vertical shrink by 1/2, which we're multiplying everything on the outside by 1/2, and then we have to distribute. Right, so now I'm going to distribute my 1/2 in. I get 1/2 x to the fifth. 1/2 of 4 is 2, and 1/2 of 6 is 3. Perfect. Done with that step. Moving on. Followed by translation left 3. So that's going to be adding 3. Or I'm sorry, yes, adding 3, but it's going to be on the inside, remember. So I have g of x equals 1/2. Now I need to add 3 wherever I see an x. X plus 3 minus 2 times x plus 3, and then plus 3. And that is my final answer. There's nothing more I can do with that. So now I'm going to go ahead and find which option that is. 1/2 x plus 3 to the fifth minus 2x plus 3 plus 3. Right here, option B. Okay, and that's all we have for today. If you have any questions, as always, please reach out. Don't forget to complete the 4.7 homework, as well as the 4.7 formative. And again, please reach out with any questions. Have a great day.